How you doing, guys? This is Joe with LVV. So we're at a Burnham Boiler job, and we had to do a lot of rewiring right over here. This transformer kept on popping. It had 9 amps on it, and that was due to a faulty zone valve. So the zone valve was creating too much amperage, taking out the transformer. So we had a change the transformer, and then we had to keep the amp meter on there and figure out which one was the bad motor or bad wire or something grounded. So we found out that the zone valve was no good, so we changed out the zone valve, and we get a call back again today and saying that there's no hot water. So now this is a little Aquastat. They call it a TPI like module, and you got 24 volts coming here and here. And this is the Aquastat right here. These two go right to here. Those two green and blue wires, they go through here, up into this box, out of here, down, and see these two green and blues right here? They go in the back of, they go right down here. See that? That green and blue, which is the TT. Okay, that tells the boiler when to come on. And so that's strictly for the hot water. So this is getting 24 volts. This little light is supposed to be lit up, and when the water gets cold, these will come together like a switch. Put this wire to that wire, and then bring it right up there. So the one wire was bringing 24 volts from the boiler through and just sitting here. And then when this Aquastat closes, because it needs to have warm water, it'll close, connect to here. So if it's coming through, say on the green, so the power just stops right here. When this Aquastat closes, it'll go from here to here, back to the blue, all the way back, up, down, in, and right into that blue. And the boiler will know that it needs hot water. That will key the circulator for this one zone, okay? And then you'll have hot water. Once it gets up to whatever you set it at, which is around like 130 here with a probably 10-degree differential. So it shuts off at 130, turns back on around 100, or if it's 10 degrees, it'll be 120, and you'll have hot water in this tank this whole time. So we have a new one we're about to put on, and I'll show you. It's real easy. This little well here. And this here is a little probe. You slide it right in here. You push it all the way in the back so that that well there touches the water inside. And it'll tell you the temperature. And when it needs it, it'll kick it right on. All right. So we have the power off right now because nothing's happening, with this module. So we have 24 here. Like I said, it's 24 present. That's supposed to power this up. It's not powering it up. So something is messed up with the little computer board. And like I said, then once it needs power, or once it needs water, it connects these two, and it will get it. So when I take this out, all it is one screw here. Take this out. This thing really just pulls right out. So we'll just take the knockout, take this out of the knockout, put a new one in, rewire it, and I'll show you how it's done. So we got the new module on, Aquastat. Just wanted to show you inside here. Okay, I don't think you'll be able to see all the way back there. However, there's a little hole in the back, and this probe's got to go in there. So you kind of just fish it in right through, and you'll see the little hole in the back there, and you fish it right all the way in. And it just sits there. Nothing else has to happen. All right, so now we're just gonna put these power wires to here. I'm gonna put the Aquastat right there. Let's do it again. Power to this side here, the white and the red, and then the Aquastat right there, and we'll fire it up. All right, guys, so we're tied in. This is tied in down here. We got the well, we got the probe into the well. All you have to do is push these two buttons in, all right, when you're sticking the new probe in. Okay, so let's say if the controller was good but the probe was bad, you always can just push these buttons in, slide the wire out, slide a new one in. Here's the 24 volts, and here is the switch for the Aquastat. Now if you notice down here, all right around 125, that's a good water temperature for hot water, especially if you have kids in the house, because you don't want them to just put the hot on and then get scalding hot water out. This is the differential. All right, so around 10-degree differential. So you got 125. When it gets down around 115 or 110, it's going to kick back on. Okay, so it's going to shut off 125. And you see how they put like a little dot there, you know, for like industry standard. You know, you can see what it says over here. It says see manual if you want to, blah blah blah. All right, but you have to remove this little tab if you want to go higher. But so more or less 125 is probably a good hot water temperature, right? This is not for baseboard. Baseboard you'd have 180, okay, for the winter. But this is just hot water for dishes and showers and washing your hands and everything like that. So again, with little kids in the house, you want to have it, you don't want it super hot, all right? And then that 10-degree differential. Differential meaning you take 10 away from whatever this is, and then it'll turn back on, all right? So let's see how it is. All right, so see now we got that SCA. Let's see if we can move some wires around. There you go. All right, that's standard. SEA1. SEA1 is status would be just standby right there. Now we're on 4, which is pre-purge. After pre-purge. After your evacuation pump right here, sucking everything out, this is going to prove that that's on, okay? Because you got to suck out all the gases, you know, inside the chamber. So if this doesn't go on, this doesn't close, and then it won't prove it, and then the machine will shut down. So as long as this tube is good and everything, now number 6, that's spark. Number 7 is improving flame. Number 8 is running, guys. So it goes through the whole series. Alright? Your inducer motor here, that sucks out that's the pre-purge. That sucks out all any gases. Alright? This closing, because this creates a vacuum, is going to continue that. It's going to prove that this is working fine. Then there's nothing blocking the flue. Alright, because that can happen too. Or if this is broken. Alright, after that happens, then the spark, then you have to prove the flame down here. Once that's good, we know that we're not just dumping raw gas into our house, then the flame kicks on. Now, this is up and running because, see that? Now we got a blinking light. Before we didn't. Alright, let me see on the back here. This is the front. Right? Top performer, immersion. Down here it says, I'm not sure if you can read it. Alright. It tells you about the temperature, it tells you the differential. Flashing green, calling for heat, which it is. See? There you go. And then solid green, when it gets the temperature around, so around 125, it's going to be a solid green. And then red, no probe. So my problem wasn't the probe, because I had no red light, I had no lights over here at all. So it'll tell you if the probe is OL, open line, if it's broken for some reason. Alright, then you just change out the probe. But mine was no lights at all, even though I had 24. So this 24, alright, that's coming from the transformer right up there. As long as you got 24, this should be working. Alright, and then this will be able to open and close with the temperature. And like I said, that blue-green goes through here into this box, down through here, and it comes out right there. See that? Right there, that blue-green. And that will tell the boiler to turn on, and that will actually supersede all the zones as well. But that's the priority. The hot water is always priority. Alright guys, well, like and subscribe, share it, and I'll see you guys next time.